right, let's take a look at the homework that you had last night. Page 158, you did numbers 2 through 10, the even. Page 158, 2 through 10, the even numbered problems. And we were solving for finding inverse trig equations. And number 2, they gave us the equation y is equal to 3 times the cosine of 2x. Again, we know how to graph that, right? But if I wanted to get the inverse, what would I need to do? Walk me through the process here, Quentin.
First, you would switch x and y. You divide away the 3. Then take the arc cosine and multiply by half. That's equal 1.
And there we go. How many have the same answer there on number 2? Number 4, Jamie, we had y is equal to 1/2 the cosecant of x over 3. What do we do here?
Switch the y and the x. And then you multiply by 2, so that gives us 1/2. Then we'll take the arc cosecant. Then we'll multiply by 3. And that's equal to 1.
There we go. So y equals 3 times the arc cosecant of 2x. How many have that? 4. Number 4. All right. By the way, this answer comes out very similar to this. And this answer comes out very similar to how this one started, doesn't it? Yeah, inverses of each other, almost. Number 6, we have y is equal to 3 times the cosine squared, 2x. And this does change things a little bit. It's very similar to this one, except for that squared, which changes the dynamic. Ethan?
I divide, or change the y and the x. And divide 3 away. Square both sides, or square root both sides?
Good, square root of both sides, and that's going to cancel the square. So we're now down to the cosine of 2y, but when I take the square root of x over 3,
square root of x over 3.
Which can't leave a fraction in the radical. So what do I have to do with that denominator? Class?
Square. Well, times 3.
There we go. We're going to have to multiply by 3 to get the square root of 3x over 9 so I can take the root of the denominator. So remember, rationalizing denominator, we have to take the root. So I'm going to make it a 3x over 9 so I can take the square root of the 9 to get a plain old 3, and we'll leave the square root of the 3x, though there's still one little detail missing. Our idea to take the square root, positive, negative. Questions on that algebra? That's all that is algebra. Questions on that? All right, now Ethan.
Multiply by half.
Not yet. The 2 is more attached to the y than the trig function is.
By the cosine away?
There we go. Let's not divide the cosine. How do I get rid of cosine? What's the opposite of cosine? Arc cosine. Take the arc cosine of both sides. Technically, when we take the arc cosine here, that cancels, just like square root cancels the square. Dividing by 3 cancels the 3. Arc cosine cancels the cosine. We'll take the arc cosine on the other side as well. And now, divide by 2, or a better way is multiply the half. That gets rid of the 2, and there's our equation. So again, considerably different because of the radical that had to be used there. Did anyone get that? You rationalized properly?
I just forgot to multiply. Well, I had square root of x over 3.
Right, you left this instead of the rationalized form. Okay, so a reminder about that from our algebra classes in years past. Let's take a look at number 8. This one's a little bit insulting, I guess. Y is equal to the sine of negative 2x. Now, everything in me is like, I want to factor out the negative. But I'm not going to bother. I'll leave the negative in there for now because it makes my life easier. What do we need to do here, Jamie?
Let's switch the x and the y first.
There we go.
Then we will take the arc sine. Then we'll multiply by a negative 1/2.
Good. Either negative half, or since this isn't a fraction, we could put it over negative 2. But then you have to pull the negative out. So maybe the negative 1/2 multiplied is better anyway, so that y equals negative 1/2 the arc sine of x. And there we go there. How many have that for number 8? Questions? Number 10. Quantum, we have y is equal to half the cosecant of x over 2. And again, this looks very similar to number 4. It's just an x over 2 instead of an x over 3, but the process really doesn't change much.
Switch to x and y. Multiply by 2. Take the arc cosecant and multiply by 2 again.
There we go. You get y is equal to 2 times the arc cosecant of 2x. Somebody had that for number 10. All right, questions on that? Maybe just a couple more, and then we'll take a look at those limited ranges again of these inverse functions and get into how we're going to use those facts that we've worked so hard to memorize. We'll raise the rest of that in a second. So if you would, I want you to find the inverse trig equation for y is equal to 3 times the sine of half x, and the inverse trig equation for y equals a fourth, the cotangent squared, 3x. Is finished. First thing we need to do, class, is always
Switch to x and y.
switch the x and y. Next thing,
Divide by 3.
divide away the 3, then
Arc sine
take the arc sine, then
times 2.
times 2, and we're done. Did we get this answer? Y equals 2 times the arc sine of x over 3. For the next one, again, we're always going to start with switching the
X and y.
x and y. Then we're going to
Times 4.
multiply by 4. Then
Take square root.
take the square root. Two thoughts here.
Can't
Or-
take square root of x.
Me too.
I'm sorry?
You can't take square root of x.
I can't take the square root of x, but I can take the square root of its factor 4 to get
2
times the,
square root.
Positive.
and the other thought was positive negative. The first thought is reduced by taking the square root of the factor. The second thing was the positive negative. Then
Arc cotangent.
take the arc, cotangent, and finally
Divide by 3.
divide away the 3, and there's my answer. Or you could multiply 1/3 times all of this, and there's our answer. How many had this or the 1/3 instead of the divided by 3? Any questions on that? Any questions on inverse trig equations? All right, well, let's go ahead and quickly review over our limited ranges. And again, just trying to make sure we've got these memorized really well. So let's come over here right across the top of Ethan's head. It's okay, I zoomed in just a little bit for you. All right, so remember the key is only 2 quadrants can be used. And we're always going to use the first quadrant for positives. So the question is, where does the negative wind up? Does it go into the second quadrant or the fourth quadrant? Well, for sine, it can't go into the second quadrant because it won't be negative. So remember, we're going to use the fourth quadrant and the first quadrant. And sine has no asymptotes. So arc sine will have no asymptotes. It's limitless, everything in between the negative 90 and 90. Arc cosine, on the other hand, remember, uses not the fourth and first, because it'd be positive in both, but first and second, 0 to 180. Again, no limitations as far as exceptions or exclusions, brackets, everything's included for sine and cosine. Tangent is going to mirror the sine, cotangent mirror the cosine. So the plain old sine and tangent match, and the plain old, the co of sine and co of tangent match. Except tangent and cotangent, remember, have those asymptotes on the edges. So we have to use parentheses on them. And then coming down here, we're going to make the secant match the cosine, except the asymptotes in the middle, and cosecant is going to match the sine, but the asymptotes in the middle. But just like these have matching brackets, these have matching parentheses, these have matching brackets, and they both have matching exceptions at the middle. Secant leaves out the middle 90, cosecant leaves out that middle 0. Again, that's kind of how I remember them. I think of them in terms of pairs, but however you need to remember them, whatever you've got to do to memorize, certainly do so. But how are we going to actually use this information, I guess, is the question. So, come back over here. I don't need a camera operator. The nice thing about Mevo is I don't need a camera operator. The downside about Mevo is I don't get a camera operator. All right, anyway, so how will we actually use this? Write this down. Y equals the arc sine of the square root of 2 over 2. Now, I want to point something out. If I asked you, what's the square root of 4 class? You would say 2. If I said that x squared is 4, you would say that x is positive negative 2. Why didn't we say positive negative here? Because here the square root was already present. Here, I took the square root of both sides. Does that make sense? So here, I'm limited by the positive that's present. Here, there was no positive present. I have to assume both. So if I say that the cosine of theta equal, or if I say, for instance, let's go with this. Let's say the sine of theta is the square root of 2 over 2. Well, I'm the one taking the arc sine. So because I'm creating the arc sine, I've got to account for multiple possibilities. I've got to account for either quadrant 1 or 2, and so theta could be 45, the reference angle, or it could be 135, kind of like here. But if I just said, hey, what's the arc sine of the square root of 2 over 2? Because the inverse function is given to me, it's assumed that whatever restrictions are placed on the arc sine are present. Just as there's a restriction here because of the positive, the pre-existence of the inverse function, not my idea to take the inverse function, right? I put the inverse function there. No, it was already there. So therefore, in this problem, whatever exclusions are built in have to be accounted for. Well, remember, arc sine has to fall between negative 90 and 90. So when we say, hey, when is sine square root of 2 over 2, plus our reference angle is 45 degrees, and we would say sine's normally positive in quadrant 1 and 2, but the pre-existent exclusion, quadrant 2 isn't in here. So I'm only going to say 45 degrees. I'm not going to say both 45 and 135. Does that make sense? So go ahead and get this down. I think I had you put this in your notes and then I suddenly deviated on you. Y equals the arc sine of square root of 2 over 2. We know the reference angle is 45. We know that arc sine's positive in quadrant 1 and 2. But we also know that arc sine's limited to negative 90 to 90. So therefore, we can't include quadrant 2. We will simply say 45 degrees. Make sense? Write this one down. Y equals the arc cosine of negative square root of 3 over 2. Y equals the arc cosine of negative square root of 3 over 2. Well, we're going to follow all the procedures and steps we used to use. We used to ask ourselves, well, when is cosine adjacent over hypotenuse square root of 3 over 2 class? 30. At 30 degrees. And then we would say, that's my reference, and then we say, well, when is cosine negative class?
2 and 3.
Quadrant 2 and quadrant 3. But because it came with the inverse function, I've got to account for its exclusion. Arc cosine only has values in its functional sense in what range?
0 to 180.
0 to 180, or 0 to pi if you're doing radians. We're doing degrees because I'd always rather do that. But 0 to 180. So which quadrant doesn't fit within this limitation? I can't use a quadrant 3 angle, so I'm only going to say y equals 150 degrees, not 210. Because again, put in one value, get out one value. That's what makes it a function. And it's only a function with that limitation. Okay? Questions on this? Kind of get the idea? Let's do another one. Let's suppose I said y is equal to the arctangent of -1. I always like making things fractions, right? So I'm going to put this as -1 over 1. And of course, the question is always, when is opposite over adjacent 1 over 1? 45 degrees. That's my reference angle. Then I'll ask myself, well, when is tangent negative?
2 and 4.
Quadrants 2 and 4. But what is arctangent's limitation?
90 or negative.
Negative 90 to 90. Now again, for now, we can turn around and look at a bulletin board, right? Homework bulletin board's not there, though you might have the cheat sheet, right? The paper that we copied out. But then come quiz test day, that's going to be covered, and you can't have the cheat sheet. So again, you see why it's so important to have this memory so you know what to pick. Which quadrant do I have to rule out? Quadrant 2. Quadrant 4 is allowed, but instead of going around to quadrant 4 to get 315, 315 is too big. Instead of going around positively, I'm going to go backward into the first quadrant and just say y is equal to,
315?
well, 315 would be going forward. But I can't do that because that's bigger than 90. So instead of going forward, I'm going to go backward.
Negative 45.
Negative 45 degrees. Does that make sense? Questions on that one? And by the way, again, what you're doing is, what would the calculator do? This is how the calculator is programmed. So if you took the arctangent of -1 on your calculator, it would spit out negative 45. Unless you were in radian mode. But then it would be negative pi over 4. Which would be like negative 0.7 something-ish. Which would be weird. You can put it in radian mode and test it. It's like, nah, I don't care. All right, questions on that? All right, how about this one? Y equals the arc cotangent of the square root of 3. Again, I like having things as ratios. So I'm going to put it over. And then I'm going to ask myself, when is cotangent, what over what? Adjacent over opposite, square root of 3 over 1? 30. That's my reference angle. When is cotangent positive?
1 and 4. Or 1 and 3.
Quadrants 1 and 3. But what's the limitation on arc cotangent?
0 to 180.
Is 0 to 180. Which quadrant do we rule out?
3.
Quadrant 3. So I'm only going to leave my answer as the quadrant 1 form, which is, of course,
150.
quadrant 1 form,
30.
30 degrees. All right, Quentin's participating well. So I know Quentin's getting this. Ethan, Jamie, are you getting this?
I hope so. I think I got it.
All right, let's take a look at another one. Y equals the arc secant of 2. All right, Jamethan.
Who?
Jamethan, the first thing we want to do is put the 2 over 1.
Overall.
And then we're going to ask ourselves, when is secant
Hypotenuse over adjacent.
2 over 1? And the answer is
60 degrees.
60 degrees. Okay, Ethan specifically, when is secant positive?
What is quadrant 1 and 4.
1 and 4. What is secant's limitation?
Is it 0 to 180?
0 to 180, except
It's at 90.
at 90 degrees, except in the middle. But that's not an issue here, because it's not 90, it's 60. Which quadrant do I have to rule out?
1.
Which of these two quadrants doesn't fit between 0 and 180? From
4.
0 to 180, that includes 1 and 2, not 4. So 4 gets ruled out. So we're going to say that y equals the quadrant 1 form of 60, which is 60 degrees. Making sense? Do you see the process here? All right, let's do this one. Y is equal to the arc cosecant of -2 squared of 3 over 3. All right. This one looks weird. right? Neg 2 squared of 3 over 3. Remember, if it looks weird, like, I don't get that, we just got to rationalize, or unrationalize it, really. Unreduce the radical. So what should we rewrite this as?
2 over square root.
Right, this is really the arc cosecant of negative 2 over square root of 3. And of course, we see cosecant. And we should ask ourselves, when is cosecant?
Positive or negative.
Well, we could ask that too. I usually ask when is cosecant, which is
Hypotenuse over opposite.
hypotenuse over opposite, 2 over square root of 3.
30.
60.
60.
Then I'll ask myself, okay, when is cosecant negative?
Quadrants 2 and 3. 3 and 4.
3 and 4. But then I also got to ask myself, what is this limitation we have on arc cosecant?
90 and 90 except 0.
Negative 90 to 90 except 0. Okay? So which quadrant gets ruled out?
4.
Oh.
And 3.
From negative 90 to 90.
3.
3 gets ruled out. 4 and 1 are included, but not 3. So we're going to go with the quadrant 4 form of 60. But again, normally my quadrant 4 form of 60 would be what? 300, correct? But I can't say 300. I can't go all the way around to 300 because that's too big. I can only go up to 90. So instead of going all the way around to 300 positively, I'm going to go to the same point backward.
Negative 60.
Negative 60 is my answer. Questions on that? Making sense? All right, turn your textbooks now. So you're already in your textbooks, page 158. Now you see those problems, by the way, on numbers 11 through 15. Okay, those problems very similar to what we were just doing. But you look beyond that, and it starts to up the ante just a little bit. Look at number 16 and copy it down, if you would, please. We're going to work this through together. Number 16, y is equal to the sine, get the chalk to stay put, of the arc cosine of negative square root of 2 over 2. Y is equal to the sine of the arc cosine of negative square root of 2 over 2. Copy that down if you haven't already. Well, as we work our way to the y, to solve for y, we start furthest from the equal sign and kind of work our way back. So we're going to start here. We're going to take the sine of something, but we've got to figure out what is the something. Here's what I want you to remember. Whenever you see an arc function, an inverse function, you're going to ask the question, when? That's what we've been doing this whole time, really. When is cosine square root of 2 over 2? Well, we know that's really the rationalized form of 1 over square root of 2. Okay, so when is cosine adjacent over hypotenuse 1 over square root of 2 class? 45. So we know the reference angle here is 45. Then the question becomes, when is cosine negative?
Quadrants 2 and 3.
Quadrants 2 and 3. But we're not allowed to have both quadrants. Remember, we're only allowed to have one. Which quadrant gets kicked out based on the limited range of arc cosine?
0 to 180.
Right, 0 to 180, so we can't have quadrant 3. So I'm going to go with the quadrant 2 form of 45 to get 135. So all of this becomes 135 degrees. Do you have that down? So we know it's limited between 0 and 180. So when I say quadrant 2 and 3, well, it can't be 3. So it's just quadrant 2, so just 135. When we come here, the next question becomes what? For a regular trig function, it's just what? For instance, what's the reference angle? And this shouldn't be hard to figure out because we wrote it out a second ago. 45. Also, what quadrant are we in? Well, we just determined we're in quadrant 2. What is the sine of 45? 1 over square root of 2, which becomes, what is sine in quadrant 2? Positive. So there's my answer. Kind of work our way backward. Starting with the when because of the inverse function, then the question becomes what? Copy to number 18. Do this with me. Y is equal to the arctangent of the cotangent of 4 pi over 3. And notice they go in for radians, so get ready to think radians. Now notice we're not starting with the inverse function, class. We're starting with the regular function. We're going to start right here. So my question should be, what? for instance, what is our reference angle?
60.
60. 4/3 of a pi. What quadrant are we in? 3. What is the cotangent of 60? What is cotangent in general?
It's 1/3.
Adjacent over opposite. So what is the cotangent of 60? 1 over square root of 3. By the way, I would not, since it's not a final answer, we still got one more step to do, I wouldn't rationalize it. Strategy tip. Don't rationalize yet. What is cotangent in quadrant 3? Positive. So all of that becomes this. So we have y is equal to the arctangent of positive 1 over square root of 3. So far, so good? Now, my question changes because we're dealing with an inverse function. So my question becomes, when? When? All right, when is tangent positive?
1/3.
When is tangent, opposite over adjacent, 1 over square root of 3? 30. But I can't have two answers, remember, because this is an inverse function. Inverse function is limited to one solution. Which solution must I rule out? Quadrant 1 or quadrant 3?
3.
I have to rule out quadrant 3. It's negative 90 to 90 in parentheses. So that rules out quadrant 3. I must go with the quadrant 1 form of 30, which is 30 degrees. And there's my answer. Questions on that? Starting to get a feel for this a little bit? Okay, we've got a couple more still to do before I'm ready for you to try it on your own. But again, it's just what quadrant? What's the reference angle? What is this? Okay, now we switch to when. Okay, when is it this? When is it that? But we can't choose both, so we're going to narrow it down. Here we started with the when. When is it negative? When is it 1 over square root of 2? Okay, but we have to choose 1. Okay, now what is the sign of this? Let's look at number 20. We have y is equal to the sine of the arctangent of negative square root of 3 over 3. I look at negative square root of 3 over 3 and I think to myself, yeah, I don't like that. Yeah, let's unrationalize it and make it a negative 1 over square root of 3. Which question do I start with? What or when? When. It's an inverse function. I'm going to ask the questions when. For instance, when is tangent? Negative. Okay, that's a great question to ask. When is tangent negative, class?
2 or 4.
Another good question to ask is, when is tangent 1 over square root of 3?
30 degrees.
Yes. But remember, you're not allowed to have both of them. You're only allowed to pick one. Which one do I pick? Quadrant 2 or quadrant 4?
4.
Quadrant 4. Remember, arctangents between negative 90 and 90. That rules out quadrant 2. So I'm going to go with the quadrant 4 form of 30. Which normally would be 330, but as Quentin points out, if it's negative 90 to 90, I can't say 330. So I'm going to go backwards and say negative 30. So all of this becomes negative 30 degrees. Making sense? Quentin's showing off and earning favorite student status right now. Ethan had a chance yesterday, blew it. All right. Like the Georgia Bulldogs. Anyway, we're not going to start that again. I'm not going to lie though. I went back last night and I rewatched that part of the lesson. I fast forwarded until I got to that part of the lesson. I was like, I got to watch that again. I had so much fun. Poor Chris. All right. I did pray for you this morning though, Chris, that you would be feeling better and rejoining us soon. And the Lord would help you to understand these videos as they're coming out. And Rebecca Beatty.
And why Georgia keeps listening to that.
I did pray for that. Anyway. So we come here and my question becomes, what? For instance, what do we do when we've got sine of a negative angle? Pull the negative out. So this becomes the negative sine of 30. That's what is my negative angle identity for sine? What is the sine of 30? 1/2. So my answer is negative 1/2. We're done. Easy. Figure the when, get the what. Now here's another thing you might want to jot down. Remember, inverse functions give angles. Regular functions give ratios. If it's an inverse function, you are going to get an angle. If it is a regular function, you are going to get a ratio.
So these are inverses.
These are inverses, these are regular. Regular, inverse. Inverse, regular. Right? It's just depending whichever one you're doing. One you get an angle, the other you get a ratio. Let's do one more together, and I'm going to have you try one or two or three on your own. Number 22. Like, I shouldn't lie. It's going to be free if you're going to try. We'll try them one at a time, though. We'll build. All right, so numero 22. Y equals the arc cosine of the sine of negative pi over 3. My first question is what? Because it's a regular function. So you might even want to put that down. Inverse functions are when, regular functions are what? Also, since it's a regular function, I'm going to get not an angle right now, but a ratio. I'm going to get some kind of ratio. But I'm going to start with this question. I've got sine of a negative angle, right? What do I do when there's sine of a negative? So negative sine of pi over 3. What do I do when sine is negative? Pull it out. By the way, what over cosine of a negative? Disappeared. But it's sine, right? It's an odd function. Then I ask myself, pi over 3. What is that? 60 degrees. So this is really the negative sine of 60 degrees. Then I ask myself, what is the sine of 60 degrees? So the whole thing becomes a negative square root of 3 over 2. Questions? Again, do we have to necessarily do it this way? No. We can kind of scribble stuff off to the side, that's fine. But this is what we're doing. Now, the question changes. Class, now the question becomes when. And as I do this, by the way, I'm going to be getting what kind of answer for my final answer? I'm going to get some kind of angle for my final answer. When is cosine negative?
2 and 3.
When is cosine square root of 3 over 2?
30.
But I can't keep both 30s. I'm going to get an angle singular. Okay, I can't get two angles. Which quadrant's angle do I kick out?
2 or 3.
Quadrant 3. Because remember, our cosine is 0 to 180. Again, that's why you have to have those ranges memorized. It's 0 to 180. So when you kick out the third quadrant, I'm only keeping the second quadrant, which is 150. And there's our answer. Feel like we're getting the hang of this? Do number 24 seats. Numero 24. At O, your seats O. As Ethan O says, uh-oh.
So you kept all the Georgia things in there in the video?
Oh, I did, yeah.
Good.
Because I enjoy it. Now, if Victoria watches these videos next year, will she appreciate? I don't know. But she's doing geometry right now, so if she does videos again next year, she would do.
Your cousin?
A niece. I guess when Gavin gets to it in a couple more years, he'll be like, I don't care about football. But at least we enjoy it, right? Like, as long as we're having fun, who cares about the video student? I'm just kidding. Care about our video students. If we didn't, we wouldn't be recording this.
Just kidding.
No, I really wouldn't be. Well, I mean, there is the added benefit to me if I'm ever out sick and I show a video of myself. instead of a video of some other person who teaches differently, you know?
Yeah.
Gotta be something to be said for that. Anyway, you're doing 24. Check your work. If you're good, move on to 26. If you're confused, ask a question. People on video are really
36.
hoping you're watching a bit. 26 once you finish 24, if you're good. Yes, ma'am.
Where's the negative? Oh, okay, so secant. The secant is
Negative in quadrant 3. All right, so at the very beginning it was 1. What quadrant is this? It's quadrant 3.
okay.
What is the reference angle? It's 30. What is the secant in quadrant 3? It's negative. What is the secant of 30? It's 2 over square root of 3. And then it becomes when? Well, when is cosecant negative? Quadrants 3 and 4. When is it 2 over square root of 3? It's 60. But I mean, instead of both 60s, I only need to keep 1. And it can't even be 300. It's got to be negative 60. Gentlemen, you're both good?
Mm-hmm.
All right, 26. Same thing when you finish 26. If you're good, go on to 28. If you're not good, ask a question.
Is it 30?
28.
28.
Kind of working our way down the evens there. Though if I remember right, 30 is a bit of a doozy. Does 30 look worse than the others?
Yeah, it's a fifth one.
2 times the square root of 5.
Yes, I think that one's the one we're going to wait till you've mastered the art until we...
Which is never so.
Oh, for shame. So defeatist. That's like saying, well, Georgia will never beat Bama. Don't have a defeatist.
I'm not
Think
saying that.
positive.
I'm not saying that.
Georgia could beat Bama. This could be their year. They have hope.
Like they did in the SEC championship. I'm so shocked. I've never seen that Bama team play like that before this whole year. Bryson's gonna get eyes. Should have this kid. And who else is gonna get it?
I know, there really haven't been a lot of great
Yeah.
standout athletes this year. Like, there have been really good team efforts, but there hasn't been one dominant guy. Now, if you're looking purely stats, Western Kentucky's quarterback is awesome. But, you know, he plays in like, what, the MAC or something like that. So, Conference USA, whatever it is. It's like 5,000 yards, 50-something touchdowns. It's crazy. But he plays nobody, so nobody cares.
I'm watching him get Heisman.
I tell you, one bowl game that intrigues me, and it's a no-name bowl game, right? But Western Kentucky and Coastal Carolina. You know, Coastal Carolina's made a name for themselves the last 2 years.
Mm-hmm.
And Western Kentucky has this great quarterback, so I'm like, should be interesting. All right, speaking of interesting, questions on 26. Are we all good on 26? Ready to move on? We're all moved on to 28?
Mm-hmm.
All right. For the sake of the video, then, in case there's a question, when is tangent positive? 1 and 3. When is tangent opposite over adjacent, square root 3 over 1 at 60? So we're ignoring this negative at first. That's going to be the quadrant 1, because we can't have quadrant 3, negative 90 to 90, form of 60, and then the negative just comes down. What do we do with the sign of a negative? Put it out front. What is the sign of 60? Square root 3 over 2, and then that negative just kind of stays at the front the whole time. All right, questions on 28. Were we able to follow 28 all the way through? Mm-hmm. All right, I'm going to give you 3 of these for homework to make sure we don't lose the skills we've been working on. And so for homework this evening, page 158, numbers 19, 23, and 27. For homework this evening, page 158, numbers 19, 23, and 27. We are looking ahead at a test coming up on Tuesday. Test coming up on Tuesday, that's lesson 83. And that test will be over chapter 7. Test Tuesday over chapter 7. The exam will be in lesson 87. So there's no new material between the test. After we take the test, it's just a review for a couple days. Then we take the exam over the entire semester. So no new material between test 5 and the exam. But test Tuesday, lesson 83.
1923,
19, 23, 27 on page 158. All right, have a great day. You are dismissed.